Hi, I'm Juan Perdomo.
I'm Matt Goldberg.
I'm Lloyd Larus-Stone.
Given the importance of finding similarities in big data and patterns, we decided it would be fun for our final project to implement clustering algorithms that work on graphs, specifically weighted undirected graphs, and the two algorithms that we decided to implement were a modified version of Kruskal's algorithm and a Markov clustering algorithm.
So, as Juanqui described, there are two algorithms, the Kruskal's algorithm and the Markov algorithm, and we're going to show you a few examples of how we use them. This initial data set, as you can see, has two distinct clusters, A and B, C and D. So when we run Kruskal's on this algorithm, we would expect to see that. And as you can see right here, we do get these two distinct clusters with nice distance between them.
Now when we run Markov on the same thing, we'll notice we get the same two clusters with the same stats.
And this is to be expected. When we try it again on a larger data set, we're hoping to get a similar result. So as we show you this example, I want to talk a little bit about the differences between the Markov and Kruskal in terms of performance. So Kruskal's is actually a little bit faster on very large data sets, noticeably so in fact, but it's better at picking out the outliers of the data set as opposed to Markov clustering algorithm, which is, while slower, is better at discovering the large groups of clusters.
So basically what we do is we set up the transition matrix, and then we expand it by multiplying it by itself a certain number of times, and inflate it, which is basically a technique where it represents strong currents becoming stronger and weak currents becoming weaker until we reach an equilibrium, which represents our cluster.
And the Kruskal algorithm works by finding the minimum spanning tree of the graph and then cutting the n largest edges to create n plus 1 clusters.